Hello students, we are going to solve exercise 13.1, that is question number 6th one. Okay, so the sixth question is, a medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its end. The length of the entire capsule, is 14 millimeter, and the diameter of the capsule, is 5 millimeter. Find its surface area. Now capsule shape you all know, and the diagram is also given in the textbook. Now let's analyze. A medicine capsule is in the shape of a cylinder. So we come to know cylinder with two hemisphericals stuck to each of its end. So when we analyze and try to find out, so let's understand here. So there is a hemispherical end at both the places. So this is one hemispherical end, and here also one hemispherical end is there at both the ends. Okay, and the total length of the capsule is given as 14 millimeter, and the diameter of the capsule. Now this diameter will be throughout the same thing. Diameter of the capsule is 5 millimeter. Now why the word diameter is used? Because there is a hemisphere at both the ends and the diameter is 5 millimeter. You have to find the surface area. As we are going to learn the combination of the solids. Okay. So surface area means the outer surface. You have to find the total surface. So it's a combination of cylinder and hemisphere. So the total surface area will be the surface area of the cylinder plus the surface area of the hemisphere. Right? Now surface area of the cylinder, we know the formula. The formula for curved surface area is 2 pi RH. We know the R because R is uniform for cylinder and hemisphere. It is one and the same. So do we know the height of the cylinder? We can find the height of the cylinder very easily. Correct? Because the total height is given as 14 millimeter of the capsule. The total height is 14 millimeter. We know this is 5 millimeter is a diameter. If 5 millimeter is a diameter, we can find what is the radius. So 5 divided by 2, that will give you here 2.5. You all know that the radius and the height of the hemisphere is same. The radius and the height of the hemisphere. So if this is 2.5, this is also 2.5, and here this is also 2.5. So out of this 14, this much is 2.5. Here this is 2.5. So the height of the cylinder will be 14 minus 2.5. 2.5 plus 2.5 is 5. So 14 minus 5 will get the height of the cylinder. Okay. So let's understand here. So here when we write the solution, here we understand that there is a combination of cylinder here. So here for cylinder, what are the facts we know? So for cylinder we know that R is nothing but 5 upon 2, that is 2.5 millimeter. And the height of the cylinder H, we can take it as it is 14 minus, we are subtracting 2.5 plus 2.5. So we get 14 minus 5, that is 9 millimeter. 14 minus 5 is 9 millimeter. So we know R, we know H. Similarly for hemisphere, if I say for hemisphere, we require only R, and this R is nothing but 2.5 millimeter. So R is same for both, so we have denoted by R. So radius of the hemisphere and the height of the hemisphere will remain the same. Okay. So let's go to the problems. You have to find the surface area. Therefore, surface area of the capsule. So here surface area of the capsule is a combination. So it is nothing but here this portion which is covered here, only that the outer portion, that is nothing but the CSA. So CSA of the cylinder plus we have CSA of the two hemisphere. Now two hemisphere, when we join it, actually becomes a sphere. So we can just write it is 2 into CSA of hemisphere. 2 into CSA of hemisphere. We can write it together because we can take common. Because here the radius is same in both the cases. So CSA of cylinder, you all know it is 2 pi RH. And here CSA of a hemisphere is 2 pi r square. As I said, two hemisphere will make a circle. So 2 into 2 pi r square. So can I take common here 2 pi r, here also 2 pi r. So when I take common 2 pi r, we'll get H plus, so I have taken here 2 pi r, so H will remain here. I have taken 2 pi r, so here 2 will remain here, and 1 r, so 2 r. I hope this is very clear. So in this way, if you do, the calculation becomes very easy. So 2 into 22 by 7 pi value. R value we know it is 0.0 Okay, not 0 point, sorry. It is 2.5. So R is 2.5 here. H. H is 9. Okay. 9 plus 2 into 2.5. So here we have 9 plus 2.5. So 2 into 25. 25 2 is 50. So we know 2 into 22 by 7 into 2.5. Here we have 9 plus 5. Right? So here 9 plus 5 is nothing but 14. So I'll just do here. So we have 2 into 22 by 7 into 2.5 into 14. So can we cancel? 7 2s are 14. Here we have 2 into 22 is 44. Again 2.5 into 2 is 50, that is 5. Here point is SO 5. So here we get 5 4s are 20. Here we get 22. So 220 millimeter square. Here they have not asked the conversion. So hence we got the surface area of the entire capsule. The whole surface area is 220 millimeter square. Hello. So now we will do the next sum. A tent is in the shape of a cylinder surmounted by conical top. This is the 7th question. If the height and the diameter of the cylindrical part are 2.1 and 4 meter respectively, and the slant height of the top is 2.8 meter, find the area of the canvas used for making the tent, and also find the cost of the canvas of the tent at the rate of rupees 500 meters. First time we read it is just a week. Then second time read it carefully and try to predict the diagram. This is very very important. It has come in the board exam, this type of questions. Okay. So let's try to interpret with the diagram. A tent is in the shape of a cylinder which is surmounted. So cylinder surmounted. So it is mounted by a conical top. So let's try to draw the diagram. As I said, you can draw it rough. So there is a cylinder and there is a cone. Okay. So there is a cylinder. Okay. So this diagram here. Here we can find. So a tent is in the shape of a cylinder which is surmounted by a conical top. The height and the diameter of the cylindrical part are 2.1 and 4. So 2.1 is the height, 4 is the diameter. So the first one is represent the height of the cylinder. So the height of the cylinder is 2.1 meter. So here if you represent diagrammatically you will understand. Diameter is 4. So what is the radius? Usually we want radius. So diameter means is 4. So radius is 2. So we know R, we know H. Then it is given slant height of the top. So slant height of the top means conical. This is given, L is given as 2.8 meter. Correct? Find the area of the canvas making the tent. So area of the canvas they are saying, that means the outer part, how much canvas is required for making the tent. Correct? So when we require for area of the canvas, so it is nothing but cylinder plus the conical. So to find the area of the canvas, we want the CSA of the cylinder and the CSA of the cone. So here, to find the area of the canvas that is used for making the tent, we require CSA of the cylinder plus CSA of the cone. CSA of the cylinder formula is 2 pi RH. So do we know R? We know H. Okay. What is CSA of cone? CSA of cone is pi RL. So here R we know, L we know. So all the things we know. So while jotting down, we will just write for cylinder, and for cylinder we have R as that is 4. It was given. So 4 upon 2, that is 2 meter. H is 2.1 meter. For cone we know L is given as 2.8 meter and R is 2 meter. So we have jotted down what we require for cylinder, for cone. Next we start. Let us find the area of the canvas. So here we write, therefore area of canvas. So we will write together. Again I can take common because R is same. So area of the canvas required for making tent, will be equals to, it is CSA of cylinder plus we can say CSA of cone. Okay. So I write here. So this is nothing but, here I can just write CSA of cylinder is 2 pi RH plus pi RL. What is common here? Pi R and pi R common. So when I take pi R common, we get here 2H plus L. So let's substitute and get, therefore area of canvas that is required for making the tent, blah blah. Let's substitute. Pi is 22 by 7 into R. What is r here? 2. So from the diagram it becomes very easy to see. So pi r 2 into h. So h is nothing but 2 into 2.1 plus L. L is 2.8. So 2.8. So let's calculate. So we get 22 by 7 into 2 into, here we get 21 into 2 is 42. So 4.2 plus 2.8. So here we get 22 by 7 into 2. Here we have 8 plus 2, 10, 5, 6, 7. So 7. So this will cancel. So very easily we get the answer 44 meters square. So we found out the area of the canvas. Now what they are asking, also find the cost of the canvas. This is very easy. So we know how much meter square there is, 44 meters square. Area per meter square is given as 500 meters square. Therefore, the total cost of canvas equals to, here we have, that is 44 into 500, that is equals to 0, 0, 5 4s are 20, 0, here 22. So this is this much, here we can say 22,000 rupees. Now the common mistake made by the students in this is this one. That is, the base of the tent is not covered. Now this will be not given in the exam. So whenever your tent is there, a cylinder and a cone, here the base is never covered. Okay. So what is the usual mistake? Students take CSA of the cylinder, CSA of the cone, and they take pi r square also. So which we have not included. So now in the textual question they have written the base of the canvas is not, the base of the tent is not covered. So this you have to understand when you consider the area of the canvas required for the tent. When it is cylinder and a cone, you just have to consider the CSA of the cylinder and the CSA of the cone. Okay. Moving to the next sum, that is question number 8. Let's read the sum. From a solid cylinder means imagine that wood, solid cylinder we have cut, okay, whose height is 2.4 centimeter and the diameter is 1.4 centimeter. A conical cavity of the same height and the same diameter is hauled out. Okay, let's try to understand. To find the total surface of the remaining solid to the nearest centimeter square. So if you try to predict the diagram, so we come to know that there is a solid cylinder. Okay, the solid cylinder is there, and from that solid cylinder, from one of the base, a cone is hauled out. It's removed. Okay, so it is like a drilled, it has been removed here. The cone is removed from here. From the top portion it is removed. Now they are asking what is the total surface area of the remaining solid. Now here in this cases, when you get confused, I'll just tell you, when total surface area we have to find, imagine which surface you are going to paint. So if you see that what you are going to paint, so here there is a cylinder. So let's try to imagine. So here there is a cylinder. Okay. Now from the cylinder, so this is solid cylinder, but this is my hollow cylinder. So imagine this is a solid cylinder and a cone has been removed. So when a cone has been removed, how it will look? Just check out. So inside it will be a cone, because a cone solid like has been removed. So if I want to say find the total surface of the remaining solid, so what will be the total surface? Let's try to analyze. So here I will paint. Here I am going to paint. So this is CSA of the cylinder. This I will paint this surface. Okay, that is nothing but pi r square, area of a circle, and the cone. Now this cone radius and the height is the same. So the cone is also I am going to paint. The cone, which portion I am going to paint? Only the CSA. Right? So here the total surface of the remaining solid is nothing but CSA of the cylinder plus area of the base and the CSA of the cone. I hope this is understood. Now I have just inserted for you to make you understand that a cone. So if this is removed, a cone solid portion, so inside also it will be a conical shape. Okay. So here you will just write down. Before that, let's check out everything is there. So we know CSA of a cylinder is 2 pi RH. So we know H, we know R. So we know both. Now for CSA of the base, pi r square. And for cone we require pi RL. So L we require to find out. So once we know all, then we just have to substitute and get the answer. Okay. So let's start. Here they have given that cone and the cylinder have the same radius and height. So here we can write for cylinder and cone. For cylinder and cone, we have What is H? H is same, that is 2.4 centimeter. R is nothing but diameter upon 2, that is 1.4 is the diameter. So here this will be 0.7 centimeter. Okay. So for cylinder and cone, R and H remains the same. So our task is to find L. So we know that L is nothing but square root of R square plus H square. So let's find L. So once we find L, then our work becomes easy. So what is R square? 0.7 the whole square plus H square, that is 2.4 the whole square. 24 square is 576 and here 0.7 square is nothing but 49. So 0.49, here we get 5.76 because 2.4 into 2.4, we know 576. We have to put the point after two numbers, correct? So when we add here, we get 5 plus 7, 15, 11, 2, so 6.25. And we know square root of 625 is 25. So square root of 625 is 25. So here point. So here this is nothing but 2.5 centimeters. So once we know our L, R, H, we can directly substitute. So here we can write, therefore TSA, or the total surface area of the remaining solid equals to, here we can say this is nothing but CSA, as I said, CSA of the cylinder, okay, so that we will paint. Then we need to paint the area of the base. Only from one side it is covered. So here, that is area of base plus inside we have a cone, conical shape. So what will remain? Cone. So CSA of cone. So let's substitute the formula. CSA of cylinder is 2 pi RH. Here we have pi r square. Here we have pi rl. Can I take common pi r? Can you see pi r, pi r, pi r? So when I take pi r common, what will remain inside? Here 2h. Here 1 r will remain and here l. So let's substitute 22 by 7 into, what is my r? R is 0.7. Here 2 into h. H is 2.4 plus R is 0.7 and L we found out as 2.5. Okay, so this is just a calculation part. So you found that whenever we do it together, the calculation becomes very easy. We don't have to really struggle for doing calculation. Okay, easily we are doing. If you find separately, it will become more lengthier, right? So here we get 0.1. So we get 22 into 0.1. Here 24 into 2 is 48, that is 4.8. Here we can just subtract it, add it, 7 plus 5, 12. So we get 3.2, correct? So here we can write 2.2. Here 8 plus 2, 10, 8. So here we are left with 2.2 into 8. So which is 8 2s are 16. 16, 17. So 17.6 we get the answer, that is in centimeter square. Now they have said that find the total surface area to the nearest centimeter square. Now after the point here, if it is 5 or more than 5, then we round it up. So here we can say approximately it is 18 centimeter square. So at the last, don't forget to write the final answer. Therefore the total surface of the remaining solid rounded to the nearest centimeter square is 18 centimeter square. So students, ninth sum is similar, where you have a cylinder and hemisphere is carved out at both the ends. So you can find the total surface area and you can try near. Okay, thank you.